The National Electrical Code (NEC) does not typically mandate separate services for multiple tenants within a building when a rated firewall divides the structure. According to Section 230.79, in multiple occupancy buildings, each individual service is permitted to supply a single unit or multiple units within the building. However, the local authority having jurisdiction, OJ, may require a separate and additional service for the two suites on the other side of a rated firewall. This mandate might stem from local ordinances or fire code requirements that exceed the stringency of the NEC. These additional requirements often address redundancy in the event of a fire or other emergencies, specific fire safety concerns related to fire spread through the firewall, and local policies that govern electrical service distribution. In such instances, there are several ways to proceed. Firstly, you can comply with the mandate by installing a separate service for each set of two tenants on the other side of the firewall, but this will likely entail additional materials and labor expenditures. Secondly, you can appeal the decision. If you believe that the AHA mandate lacks justification based on the NEC or other relevant local codes, the decision can be contested through the appropriate channels. Thirdly, you can seek alternative solutions. Investigate alternative methods that could alleviate the AHA concerns without necessitating a separate service. This could involve installing enhanced fire safety systems or incorporating a fire-rated transfer switch that links the two sides of the building for emergency situations. Other electrical contractors may have faced analogous situations. Consulting with local experts and thoroughly reviewing the AHA-specific requirements in your area is always recommended to ensure compliance and prevent potential disputes. When addressing these issues, remember that the primary service disconnect must be readily accessible as per NEC Section 230.70 AON. This means it needs to be located either outside the building or inside nearest the point of entrance of the service conductors. Section 230.71 limits the number of service disconnects to 6 per service. If additional disconnects are required, a main service disconnect must be installed. Regarding feeders, Article 215 of the NEC covers feeder requirements. Feeders carry power from the service equipment to a subpanel or branch circuit panel. They must be sized adequately to handle the calculated load, following the guidelines in Article 220. For a voltage drop, the NEC recommends limiting voltage drop on feeders to 3% for power, heating, and lighting loads, or a maximum of 5% for the combination of feeder and branch circuit. This is a recommendation, not a mandate, but it's good practice. In the context of the described building scenario, each of the 4 200 amp subfeeders must comply with these feeder requirements. When dealing with a 2-hour firewall, it's critical to maintain the fire rating when penetrating the wall. Any penetrations must be properly fire stopped using approved materials and methods as specified by local building codes and fire codes. The electrical installation needs to adhere to NEC 300.21, which requires that electrical installations not compromise the fire-resistant rating of walls, floors, or ceilings. Grounding and bonding are essential for safety. The grounding system must comply with Article 250 of the NEC. This includes grounding the service neutral, bonding metallic enclosures, and ensuring a low-impedance ground fault current path. Separately derived systems, such as those that might be created with separate services, have specific grounding requirements outlined in NEC 250.30. Surge protection is also important. Although not mandated in all cases, surge protection devices, SPDs, can protect sensitive electronic equipment from voltage surges. NEC 230.67 requires surge protection for dwelling units and is a good practice for commercial buildings as well. For multi-tenant buildings, SPD can be installed at the service entrance or at subpanels. Wiring methods must comply with Chapter 3 of the NEC. Common wiring methods include electrical metallic tubing, rigid metal conduit, RMC, and non-metallic conduit such as PVC. The choice of wiring method depends on the application and local requirement. Cable types like MC cable are also frequently used for feeder runs. Overcurrent protection is crucial. Each feeder must have overcurrent protection, such as circuit breakers or fuses, sized according to the ampacity of the conductors. Article 240 of the NEC provides detailed requirements for overcurrent protection. Coordination studies might be necessary to ensure that overcurrent devices operate in a coordinated manner to minimize downtime. In this scenario, each of the 200 amp subfeeders must have appropriate overcurrent protection at the service equipment. Regarding working space, sufficient working space must be provided around electrical equipment for safe operation and maintenance. NEC 110.26 specifies the requirements for working space, including minimum depth, width, and height clearances. This working space must be kept clear and accessible. Labeling is another important aspect. All electrical panels and disconnects must be clearly labeled to indicate their purpose and the areas they serve. This helps prevent confusion and ensures that personnel can quickly identify and energize circuits when necessary. NEC 408.4 requires that circuits be legibly identified. Load calculations are essential for proper sizing of electrical services and feeders. Article 220 of the NEC provides detailed guidelines for calculating the electrical load of a building or portion of a building. These calculations take into account factors such as lighting, receptacles, HVAC equipment, and motor loads. The calculated load is used to determine the required ampacity of conductors and the size of overcurrent protection devices. Energy efficiency is increasingly important. Many local jurisdictions have energy codes that require energy-efficient lighting, HVAC systems, and other electrical equipment. Compliance with these codes can reduce energy consumption and lower operating costs. The NEC includes requirements for energy efficiency in Article 220, Part Roman 3, and Article 404. Wiring devices, such as receptacles and switches, must be of the proper type and rating for the application. Receptacles must be grounded and, in some cases, ground fault circuit interrupter (GFCI) protected. Switches must be rated for the voltage and current they will be switching. Article 406 of the NEC provides requirements for receptacles, cord connectors, and attachment plugs. Conductor ampacity is determined by the insulation type, temperature rating, and insulation conditions. NEC Table 310.16 provides ampacity ratings for various types of conductors. Correction factors must be applied when conductors are installed in conditions other than those specified in the table, such as in high ambient temperature environments or when multiple conductors are bundled together. The use of aluminum conductors is permitted in many applications, but they must be properly terminated and protected to prevent corrosion. NEC 110.14 requires that terminals for aluminum conductors be identified for use with aluminum. Antioxidant compounds should be used when terminating aluminum conductors. Temporary wiring is sometimes necessary during construction or renovation. Temporary wiring must comply with Article 590 of the NEC, which includes requirements for grounding, overcurrent protection, and GFCI protection. Temporary wiring must be removed promptly when it is no longer needed. Hazardous locations require special wiring methods and equipment to prevent explosions and fires. Article 500 of the NEC classifies hazardous locations based on the type of hazard present, such as flammable gases or combustible dusts. Wiring methods and equipment used in hazardous locations must be approved for the specific class and division of the location. In healthcare facilities, additional requirements apply to ensure patient safety. Article 517 of the NEC covers electrical installations in healthcare facilities, including requirements for essential electrical systems, isolated power systems, and grounding. Special attention must be paid to minimizing the risk of electric shock in patient care areas. For swimming pools and spas, strict requirements apply to prevent electric shock hazards. Article 680 of the NEC covers electrical installations in and around swimming pools and spas, including requirements for bonding, grounding, GFCI protection, and underwater lighting. All electrical equipment used near swimming pools and spas must be listed and labeled for that purpose. Renewable energy systems, such as solar photovoltaic, PV, and wind power systems are becoming increasingly common. Article 690 of the NEC covers the installation of solar PV systems, including requirements for disconnecting means, overcurrent protection, and grounding. Article 694 covers small wind electric systems. Coordination with the local utility is essential when installing renewable energy systems. Electric vehicle (EV) charging equipment is also becoming more prevalent. Article 625 of the NEC covers the installation of EV charging equipment, including requirements for disconnecting means of current protection and grounding. The charging equipment must be listed and labeled for its intended use. Marine locations, such as marinas and boatyards, have specific electrical requirements to prevent corrosion and electric shock hazards. Article 555 of the NEC covers electrical installations in marine locations, including requirements for grounding, bonding, and GFCI protection. All electrical equipment used in marine locations must be listed and labeled for that purpose. Industrial control panels must be properly designed and installed to ensure safe and reliable operation. Article 409 of the NEC covers industrial control panels, including requirements for short-circuit current ratings, overcurrent protection, and marking. Control panels must be listed and labeled by a qualified testing laboratory. Fire alarm systems are critical for life safety. Article 760 of the NEC covers the installation of fire alarm systems, including requirements for wiring methods, power supplies, and notification appliances. Fire alarm systems must be installed and maintained in accordance with the National Fire Alarm and Signaling Code, NFPA 72. In summary, dealing with AHJ mandates for separate electrical services in multi-tenant buildings requires a comprehensive understanding of the NEC local codes and fire safety requirements. Compliance, appeals, and alternative solutions each present viable paths forward, contingent on the specific circumstances and priorities.